Perform the following conversions, and it tells you to refer to your textbook for SI to non-SI conversion factors that you may need. We got a whole number of them to do here. Let's just start in order. I will be taking these lower and doing each conversion. So our first one is converting 87.36 milliliters to liters. So let's rewrite that here. 87.36 milliliters equals question mark liters. So our three-step approach to dimensional analysis: write the measurement given. Our measurement given is the 87.36 milliliters, so we write 87.36 milliliters. We are now going to write the unit for our answer, which is liters, and now we need one or more conversion factors, and our conversion factor here is going to require that we have milliliters in the denominator and liters ideally in the numerator. We do have a conversion factor between milliliters and liters. 1,000 milliliters equals 1 liter. So since we want milliliters downstairs, we put the 1,000 downstairs with milliliters. 1 goes upstairs. My units of milliliters cancel. And now I'm simply going to divide our 87.36 milliliters by 1,000. When we do that, we get 0.08736 liters. 4 significant figures in our measurement. We have an exact number for our conversion factor, so I have 4 significant figures in my answer. This is a metric conversion, so we're just basically moving the decimal point 3 places to the left because I'm dividing by 10 to the third. So there is our first problem A. Let's go to B. Draw a line here and we'll put B. Scroll up and we're asked in 11B to convert 4.85 times 10 to the 4th nanometers to kilometers. So let's write our measurement given again. We have 4.85 times 10 to the 4th nanometers, and we want to convert that to kilometers. So once again, our three-step approach, our measurement given is the 4.85 times 10 to the 4th nanometers, so we write that 4.85 times 10 to the 4th nanometers. Our answer is going to be in kilometers, so let's put it way over to the right. And we notice now that our base unit is the meter, and both my starting measurement and my unit for my answer has a prefix. So the best approach to solve this problem will be a two-step approach. We first want to convert nanometers to meters, and then we're going to convert meters to kilometers. It's a lot easier to go through the base unit, in this case meters, because you should know how many nanometers are in a meter, how many meters are in a kilometer, and so on, rather than trying to figure out directly how many nanometers are in a kilometer or vice versa. So we're going to have 2 conversion factors. Our first conversion factor then is going to convert nanometers to meters. So I need nanometers downstairs and meters upstairs. Our conversion factor is 10 to the 9th nanometers equals 1 meter. So I have upstairs 1 meter and 10 to the 9th nanometers downstairs. Nanometers cancel, I'm left with meters. Now I'm going to convert meters to kilometers. We know there are 10 to the 3rd meters in 1 kilometer. So my conversion factor here is going to require I have meters downstairs, kilometers upstairs. So I've got 1 kilometer upstairs. I've got 10 to the 3rd meters downstairs. My meters cancel. I'm left with kilometers, which is the unit that I want for my answer. And now when I do the calculation, again, we're just going to be moving our decimal point. We're essentially dividing our given measurement by 10 to the 12th. So our answer, let me move my equal sign, give myself a little bit more room here. So we can do this in our heads. Our answer is going to be 4.85 times 10 to the minus 8th kilometers. My exponent of 10 to the 4th, I've got 10 to the 12th downstairs, so we're just going to subtract 12 from 4 and get minus 8. Again, we've got 3 significant figures in our answer. We've got 3 significant figures in our starting unit. Both of my conversion factors are exact numbers, as always when we're within a metric system. So my answer is going to be rounded as it is to 3 significant figures. Let's move on to C. Draw a line, and we'll scroll up and see what question C is asking us to convert. 67.055 kilograms to micrograms. Let's write that down. We have 67.055 kilograms, and we want to know how many micrograms is that. This problem is pretty much the same as the previous one in that our base unit is the gram, and in both cases our measurement given and the unit for our answer has a prefix. So again, we're going to make this a two-step process. We're first going to convert kilograms to grams, and then we're going to convert grams to micrograms. So as always, we're going to start by writing the measurement given. In this case, we've got 67.055 kilograms. Our answer is going to be in micrograms. So our first conversion then is going to be converting from kilograms to grams. There are 1,000 grams in 1 kilogram. So there's our conversion factor. And of course, we need kilograms downstairs. We need grams upstairs. So we've got 10 to the 3rd grams in 1 kilogram. My units of kilograms cancel. I now have grams. So I now want to convert grams to micrograms. We have 10 to the 6th, or 1 million micrograms in 1 gram. So there's my conversion factor. I want grams downstairs. I want micrograms upstairs. I've got 1 gram downstairs. I've got 10 to the 6th micrograms upstairs. Grams are needed downstairs, so they will cancel. So now I've got my units canceled, and my unit upstairs is the microgram, which is what I want in my answer. I have no unit downstairs, so I'm good to go. In this case, we are multiplying my given measurement of 67.055 kilograms times 10 to the 9th. So when I do this multiplication, I end up with 6.7055 times 10 to the 10th micrograms. 5 significant figures in my answer. I have 5 significant figures in my starting measurement. I don't know what happened to my units there, but these of course were exact numbers. So let's move on now to question D. So let's write our D here and scroll up and see what question D is asking us. And what happened to all my arrows? We did those. Question D, 2.2400 times 10 to the 4th milliliters to gallons. So that's our measurement given. This is a volume conversion between the metric and English system. We are given 2.2400 times 10 to the 4th milliliters. And the question is, how many gallons is that? So here we have our metric unit milliliters, and here gallons. We have our English unit. So we're going to need a conversion factor that goes between the metric and the English system for volume. And in the back of your book or in your table, you will find a conversion between liters and gallons. 1 gallon is given to have a volume of 3.7854 liters. So now I've got my metric unit here in liters. I have my English unit here in gallons. The only difference is that in the problem we are given a unit of milliliters, and in our conversion factor we have liters, but that's no problem because we know how to convert from milliliters to liters. So let's start in our usual way. We're going to start by writing the measurement given in this problem. Let me scroll this up, keep our conversion factor there. Our measurement was 2.2400 times 10 to the 4th milliliters. And our answer is going to be in gallons. So the first thing we need to do, since our conversion factor, as I already mentioned, has liters, we want to convert milliliters to liters. We know how to do this. There are 1,000 milliliters in a liter. So we've got 1,000 milliliters downstairs, 1 liter upstairs. My milliliters cancel. Now that I have liters, I can use my conversion factor that we just wrote up here that relates gallons with liters. And I'm going to need liters downstairs, gallons upstairs. So I'm going to write 1 gallon upstairs, 3.7854 liters downstairs. My liters cancel. So I'm left with gallons upstairs, which is good because my unit for my answer that I want is gallons. A little running out of space here. Let me just erase that. And now when we do the math on this, we get a value of 5.9175 gallons. Let's look at significant figures here. Our starting measurement has 5 significant figures. Remember, these ending zeros here are significant because this number has a decimal point. We only look at the number to the left of the multiplication sign for significant figures. Our conversion factor in our metric conversion, of course, is an exact number, as it always is. My conversion between gallons and liters, this is a measurement. We have 5 significant figures here as well. Therefore, my answer must have 5 significant figures. Next up is E. So let's write our letter E here. Let's scroll up and see what question E is asking us to convert. 0.00405 miles to centimeters. So let's write our starting measurement down here. We have 0.00405 miles, and we want to know how many centimeters is that. Once again, this time we're given a measurement in the English system. We want to convert it to a measurement in the metric system. We need to get across from the English to the metric system. There are several different conversion factors we can use. The one that we have in our textbook says that 1 mile equals 5,280 feet. That keeps us in the English system, but then we can also find another conversion factor that converts feet to inches. 1 foot equals 12 inches, still within the English system. And then finally, we have 1 inch equals 2.54 centimeters. So here's our final unit that we want in our answer, starting with miles right here. So as I set these up, we can see, let me use a different color here. My feet's going to cancel, my inches are going to cancel. So my starting unit of miles is going to give us our desired unit of centimeters. So we have our 3 conversion factors listed. Well, let's start by writing the measurement given, 0.00405 miles. This, of course, is over 1. And my answer is going to be in centimeters. We're probably going to have to move that because this is going to require, as you can see, 3 conversion factors. So my first conversion factor, converting miles to feet. Here's my conversion factor. I want miles downstairs, so I'm going to have 5,280 feet upstairs in 1 mile downstairs. Miles cancel. And I now have my feet. Feet to inches, 12 inches in a foot. I need feet downstairs, so I put 1 foot downstairs, 12 inches upstairs. Now my feet cancel, and I'm left with inches. And now my last conversion factor, inches to the desired centimeters. I need inches downstairs, 1 inch downstairs, 2.54 centimeters upstairs. Inches cancel. I now have my desired centimeters upstairs alone, which is my unit for my answer. So we're actually okay here. We're now going to turn on our calculator. Here we cannot just move a decimal point. We actually have to use our calculator, and we're going to get a value of 652 centimeters. We've got 3 significant figures on this answer. Let's verify that. Our starting unit, our measurement rather, has 3 significant figures. Remember, our leading zeros are never significant, so we have three significant figures. 5,280 feet in a mile, 12 inches in a foot. These are exact because they are within the same measuring system. 2.54 centimeters per inch, you would think that that is a measurement, but this is also actually an exact number as well. If you look in your textbook, you do have a triple equal sign between those two. So my answer must have three significant figures as indicated by my measurement value, which has three significant figures. So that takes care of this one. Let's move on to the next one. F is next on our list. Let's scroll up and see what question F is asking us to do. And in question F, 225 cubic centimeters to cubic inches. So this is a rather interesting problem because now we have a cubic term in both our initial measurement and our final answer. So the problem asks us to convert 225 cubic centimeters equals how many cubic inches? So again, we're going to start with our writing the measurement, 225 cubic centimeters. Our answer is going to be in cubic inches. Now, the way you start a problem like this is ignore the exponent for the time being. We're basically looking at centimeters to inches. We'll deal with the exponent later, but we need a conversion factor simply that converts centimeters to inches. We actually used that in the previous problem, 2.54 centimeters in 1 inch. So we're going to use that again. 2.54 centimeters equals 1 inch. Notice I've got the triple equal sign because this is an exact conversion. Now, because we want our centimeters to cancel, I'm going to put centimeters downstairs. So I'm going to have 2.54 centimeters downstairs, and I have 1 inch upstairs. But I've got 3 centimeters upstairs. I mean, centimeters cubed is centimeters times centimeters times centimeters. So I got 3 of them upstairs. I only got 1 downstairs. So that means I've got to do this 2 more times. I got 1 inch over 2.54 centimeters. Now I've got 2 centimeters downstairs. Still I got 3 upstairs, so I need to do this a third time. 1 inch over 2.54 centimeters. Now I've got 1, 2, 3 centimeters downstairs. That cancels my 3 centimeters upstairs. Now I'm done, because if I look now at the units that I have in my numerator, inches times inches times inches gives me cubic inches. And that's the only unit I have upstairs, and my units downstairs are all canceled. So we've got the problem set up. Now we just turn on our calculator, we do the math, and we get 13.7 cubic inches. Again, we've got 3 significant figures in our answer. We have 3 significant figures in our measurement. As I already mentioned, this is an exact number, so 3 significant figures works. Let's move on to our next problem, G. And let's scroll up and see what problem G asks us to do. It's getting longer to get up there. Problem I did in class, very similar. 55 miles per hour converted to kilometers per minute. So let's write down our starting measurement. We are told that we have a velocity of 55 miles per hour. And we want to convert this to units of kilometers per minute. Compound units, if we look at what we're given, we have the unit of miles in the numerator, and we want kilometers in the numerator for our answer. So we're going to have to convert miles to kilometers as part of this problem. The denominator has a time unit of hours. In the answer, minutes. So we're going to have to do a conversion for time of hours to minutes. So we're going to have to do 2 independent conversions, one for the numerator, one for the denominator. We can do we want to do one at a time. It doesn't matter which one we start with. But we're going to start, as we always do, with our listing of our measurement given. And in this case, it's 55 miles per hour. And I'm using the vertical line between the numerator and denominator so we have it very clear what's upstairs and what's downstairs. My answer is going to be in kilometers per minute. Again, I'm using the vertical line so that we know that miles is going to be converted to kilometers, hours is going to be converted to minutes. Our first is going to be a conversion of miles to kilometers. There's a variety of different ways you can do this. One conversion factor that's given in your book, 1 mile, is equal to 1.6093 kilometers. So here we've got a direct conversion between miles and kilometers, so that makes things pretty nice. So we're going to multiply now by that conversion factor. I need my miles downstairs, so I got 1 mile downstairs, and upstairs 1.6093 kilometers. Naturally, my miles cancel. Now please note, I have my desired unit in the numerator now for my answer. So I'm done with the numerator. Now we're going to go downstairs and deal with our conversion of hours to minutes. We all should know there are 60 minutes in an hour. I need hours upstairs. Whoops, upstairs hour. And downstairs we have 60 minutes. So my units of hours cancel. I now have downstairs my unit of minutes, which is what I want in my answer unit downstairs. Let's move the equal sign. And now we've got the desired units, so we turn on our calculator. We do the calculation. We get a value of, let me put down to 1.48 that I got on my calculator, kilometers per minute. So here's our answer. Let's check for significant figures. Is this correct for significant figures? No. Our measurement has 2 significant figures. Our conversion factor here has 5 significant figures. This, of course, is an exact number. The point here, of course, is that we've got 2 significant figures, smallest number in our measurement given. So our correct answer here needs to be rounded to 1.5 kilometers per minute. So there we have that one done. Next, H. Let's draw our line here. Write the letter H and scroll up way to the top. Get up there quickly. And H is asking us to convert 8.2 milligrams per liter to pounds per gallon. Compound units again, just like in the previous problem. So we know how to do that. Let's set up again what we're asked to do. 8.2 milligrams per liter equals question mark pounds per gallon. Once again, in the numerator, we have mass or weight units. We're asked to convert from milligrams to pounds, so we're going to need a conversion factor to go between the metric system, milligrams, and the English system, pounds. And then downstairs, similar thing. We've got a metric unit, liters, and we're asked to convert that to the English unit of gallons. So let's open our book and find our conversion factors first before we go ahead and start working the problem. Our conversion between our mass and pounds is given by the relationship 1 pound is equal to 453.29 grams. So English system grams, metric system grams, English system pounds. Our problem, of course, has milligrams, but we know how to convert between grams and milligrams, so that's not a problem. Our denominator, pounds to gallons, our textbook tells us that in 1 gallon, and I believe we've used this conversion factor earlier in this problem, 3.7854 liters. So that's a direct conversion. So let's go ahead and get started. We're going to start in the usual way. We're going to write our measurement given, 8.2 milligrams per liter. Our answer is going to be in pounds per gallon. First, we want to convert milligrams to grams. So our conversion factor, 1,000 milligrams equals 1 gram. That's something you need to know. So downstairs we have milligrams, so we put the 1,000 milligrams downstairs, 1 gram upstairs. Milligrams cancel. we now have grams, which is good because we have our relationship between grams and pounds. So now we are going to multiply by that conversion factor, which says 1 pound contains 453.29 grams. Grams cancel. So now we have the desired pounds in the numerator for our answer. So we're done with the numerator. We go downstairs now and deal with the conversion of liters to gallons. We have a direct conversion for that. So again, our liter here in the measurement is downstairs, so we need liters upstairs. Be sure you make sure you get that right. So we're going to have the 3.7854 liters upstairs and 1 gallon downstairs. My liters now cancel. I have gallons downstairs, which is what I want. So everything is set properly the way I need it. So we are now going to just turn on our calculator and do the math. And let's move our units here because this number is going to be put in scientific notation because I'm multiplying by large denominator numbers. So doing the math, we get 6.8 times 10 to the minus 5th pounds per gallon. So there's our answer. We have two significant figures, and that's because of our measurement given at two significant figures. This is an exact number, as you should know by now. This is 5 significant figures, and this also is 5 significant figures. So two significant figures, 6.8 times 10 to the minus 5th pounds per gallon. Okay, our last conversion in this problem, let's scroll up and see what they're asking for in problem I. Want us to convert 15.4 meters per second to feet per hour. Very similar to a problem we just did, another compound unit velocity. So we are given, in this case, a velocity of 15.4 meters per second. And they want us to express that velocity in feet per hour. So once again, we have compound units here. We want to convert the metric meters to the English feet. And then we want to convert, again, our time units, seconds to hours. So there are, again, several different conversion factors that you can use between meters and feet. We're going to make this pretty straightforward and just use a one direct conversion. 1 foot is equal to 30.48 centimeters. So that brings us between the English feet and the metric centimeters. As we see, the problem measurement was in meters. Our conversion factor is in centimeters. We know how to convert between meters and centimeters, so you should know how to do that. Our starting point, again, as always, we're going to write our measurement given, 15.4 meters per second. Our answer is going to be in feet per hour. One or more conversion factors. As we just said, we've got to convert meters to centimeters. We know there are 100 centimeters in a meter, or you should know that. So 100, you need to know that. 100 centimeters goes upstairs, 1 meter goes downstairs, because I need meters to cancel. I now have centimeters upstairs. That allows me to convert centimeters to feet using this conversion factor. I went centimeters downstairs, so I've got 30.48 centimeters downstairs, 1 foot upstairs. Centimeters cancel. Now, our units are what we want. I've got feet upstairs. I've got feet upstairs in my answer. We go downstairs now to the denominator, converting seconds to hours. There are 3,600 seconds. 1 hour, let's write that down, is equal to 3,600 seconds. 60 minutes in an hour, 60 seconds in a minute, so 60 times 60 is 3,600. Again, let's be careful. Seconds are in the denominator in our measurement. We want seconds upstairs, that's a 6, in our conversion factor, so that those units cancel, and I have 1 hour downstairs. So now I'm good to go, and we're ready to do the calculation. And again, let me erase my answer units because it's going to be a big number. I'm going to put this in scientific notation. So doing the multiplication here, I get a value of 1.82 times 10 to the 5th feet per hour. Again, our 3 significant figures for our answer, I've already rounded to the correct number. I have 3 significant figures in my starting measurement exact number for my metric conversion. My conversion for feet to centimeters is a 4 significant figure conversion, and my time, of course, is exact. So my answer has 3 significant figures.